Alright, so we want to write an equation for each of these two lines. So to write a linear equation, we need two things. We need a slope, our m, and we need a y-intercept, which is our b. Again, our equation is in the form y equals mx plus b. So the first thing I'm going to do is identify my y-intercept because that's normally the easiest. The y-intercept is when x is 0. So it's where the line hits the y-axis, which is 1. Again, that is when x value is 0 and where your line hits the y-axis. So then your slope, remember, is rise over run. So first when I look at this, I see that the line is going down. That means my slope is going to be negative. So I'm going to start where my y-intercept is, and I'm going to count 1, 2, 3 over 1, 2 to get to the next clear point. Again, count how many up or down it is from point to point and how far over. So again, we went negative, we went down 3, negative 3, and over 2. So my equation is y equals negative 3 over 2, or 3/2 x, plus 1. Alright, so the next one is a little different. We can still identify our slope and our y-intercept. Again, I'm going to do the y-intercept first. It's easier. I see that it's negative 1. So now my slope is rise over run. But when I see this, my rise is 0. The slope is not going up or down. Remember, the slope is also the steepness of a line. The slope here is going to be 0. It's not going up or down, it's just horizontal. So my slope, or my equation, I don't have a slope. So that would be 0x, and it's going to be minus 1. But we don't ever see that 0x. That just means there is no slope. So our line equation is just y equals negative 1. Quick review with scientific notation. So the mass of two objects is being compared during a physics experiment. It is determined that object A has a mass of 2 times 10 to the negative third power, and object B has a mass of 4 times 10 to the negative fourth power. How many times larger is the mass of object A than the mass of object B? So identifying first my question, I want to know how many times is object A compared to B. So when I'm looking for how many times larger something is, I actually need to divide. So I need to divide my object A, which is 2 times 10 to the negative third power, divided by 4 times 10 to the negative fourth. I want to figure out how much larger A is compared to B. So refresher with exponents, when I'm operating with negative exponents, remember I need to flip. Anytime I have a negative exponent, I'm going to flip where it is. So that means 2 times 10 to the negative third becomes 2 times 10 to the positive third as the denominator. When you flip it, when you take the reciprocal of it, we create the negative exponent into a positive exponent, which means the 4 times 10 to the negative fourth is going to go on top as a positive exponent. From here, dividing, I'm going to divide my whole numbers. 4 divided by 2 is 2. And then when I'm dividing with the same base, I'm going to subtract my exponents. 4 minus 3 is 1. So 2 times 10 to the positive 1 power, that's just 2 times 10, so 20. So object A is 20 times larger than object B. So looking at this one, the sun produces 3.8 times 10 to the 27 joules of energy per second. If there are approximately 31 million seconds in a year, how much energy is produced in a year? So I need to determine two things first. The first one is 31 million. I need to put that number in scientific notation. So we have to know that 31 million is written with 6 zeros. So to write this in scientific notation, I first need to figure out how many times I need to move the decimal over to get to a number that is greater than 1 but less than 10. So if I don't see a decimal, it's really at the end. So I'm going to move it over 1, 2, 3, 4, 5, 6, 7. That makes our number 3.1 times 10 to the 7th power. Now I need to figure out what operation I'm going to use. So I'm basically given the unit rate. The sun produces 3.8 times 10 to the 27 joules of energy per second. For 1 second, it produces that much. Now I know that there are 31 million seconds in the year. So in this case, I'm going to multiply. Again, it's 3.8 times 10 to the 27th power for 1 second. I'm going to multiply that by how many seconds I actually have, which is 3.1 times 10 to the 7th power. So when I am multiplying numbers that have like bases, I'm going to multiply the numbers first, and then I'm going to add the exponents since they have the same base of 10. So 3.8 times 3.1 is 11.78. And then I need to add my exponents. 27 plus 7 is 34. However, this is not written in correct scientific notation because this first number is not less than 10. So I need to rewrite this first number correctly as scientific notation, which means I need to take the decimal where it is and move it over 1 place. So that's going to make it 1.178 times 10 to the first power, because I moved the decimal place over 1, and it's a positive number, a positive exponent because it's a number that's bigger than 1. So that is just for 11.78. Then I still need to bring down, I can't forget about this 10 to the 34th power. So just like before, I'm going to multiply. I don't have any numbers to multiply with this 1.78, but now I'm going to add my exponents of 1 and 34 to get 35. So 1.178 times 10 to the 35th power is our final answer. And just as a quick refresher, if I have this number right here, 0.00047, to write it in scientific notation, I still move the decimal to, that makes the number greater than 1 and less than 10. So 1, 2, 3, 4. So 4.7 times 10 to the, except since this number is smaller than 1, the 0.00047, it's going to be to the negative 4th power, not the positive 4th power.